Blaise Pascal was born on June 19, 1623, in Clermont-Ferrand, France. His mother, Antoinette Bugon, passed away when he was 3 years old, leaving Pascal to be raised by his father, Etienne Pascal, and with his sisters. His father was a local judge and had interests in the fields of math and science, in which he had given to his son. Blaise Pascal immediately started showing off his talents in math when he was only 16 years old. He wrote an essay named Essai pour les coniques, which translates to Essay on Conics. This would be his first serious work in the fields of mathematics, as well as his first steps in becoming a leader and leaving a legacy. The book states that if you have a hexagon inscribed in a circle, then the three intersection points of opposite sides lie on a line, which is now called the Pascal line, and is known today as Pascal's theorem. Pascal's Essay on Conics was so well thought out that René Descartes believed that Pascal's father had written it, only to find out later on that it was indeed a 16-year-old Pascal who had written the essay. This is very significant to Pascal's legacy because only at the age of 16, Pascal had basically laid down the basic structure for geometry we know today. In 1642, Pascal tried to help his father in his long, exhausting calculations. Pascal was only around the age of 19 when he constructed a calculator which could only add and subtract. He had worked on it for 3 years and named the device the Pascaline. This would make Pascal almost certainly the second person to ever construct a mechanical calculator in history. The way the Pascaline would work is when the tens place gear with 10 teeth made one rotation, a second gear shifts one tooth until that gear rotated 10 times, which would be the hundredths gear. Then that gear shifts to the thousandths gear, so on and so forth. The same idea is used for odometers in cars and electric meters today. And even though the Pascaline failed to be a big success in the market at the time, the legacy of this machine can be found in the early mechanics for computer engineering. Then, in 1653, Pascal was becoming more and more influential to mathematics, and his work on treasons on arithmetic triangle, or commonly known as Pascal's triangle, helped as well. The triangle can be shown as so. Each number is the sum of the two numbers directly above it. Another pattern that can be found in the triangle is the sum of square roots. So, let's add this 1 and 3, which of course equals 4. Now, take the square root of that 4, and what do you get? 2. Another fun thing to know about the triangle is that any whole positive number can be found somewhere on the triangle. Those are just a few of the many patterns that can be found on this triangle. Pascal's triangle is significant to his legacy because it is still being put to use today. It is a good way to help teachers teach how to add to their students, and when grading, they would only have to check the last row on the triangle to see if it is correct. It can also help mathematicians today on finding the probability of things, such as a coin landing on heads or tails. This can also be applied in economics, social science, and can even help in gambling. As Pascal grew older, he began to work on hydrodynamics and hydrostatics, which centered on the principles of hydraulic fluid. As an outcome of this, two inventions were born: the syringe, which should seem pretty familiar to everyone today, and the hydraulic press. This was possible because Pascal had proven that hydrostatic pressure depends not on the weight of the fluid, but rather on the elevation difference. He demonstrated this by attaching a thin tube to a barrel full of water, and filling the tube with water up to a level of 20 meters. The outcome of the experiment was that the barrel burst due to pressure generated by the thin tube. Pascal had proven that if a thin pipe was 20 meters high, it would generate 20 meters of hydrostatic pressure. This experiment is known as Pascal's barrel experiment today. This can then lead us to Pascal's vacuum experiment, which he called vide dans le vide, which is vacuum in vacuum. Back in those days, a vacuum was very controversial because when scientists at the time would put a barometer full of mercury into a bowl or tub full of mercury, there would be some kind of force that dropped the level of mercury in the barometer, questions like what filled the space above the mercury in the tube quickly arose. Some scientists at the time said that an invisible matter existed. What really was a big question in this case was, is there really anything in there at all? If not, then what pushed the mercury out of the tube? This had become known as a vacuum because the mercury would mysteriously be sucked out, and therefore at the time it was taught that a vacuum was impossible. But to put all the controversy to rest, Pascal had thought of an experiment to get an understanding of this strange space. But because of Pascal's health at the time, the experiment was actually conducted by Pascal's brother-in-law, Florent Perrier. By filling one of the tubes and flipping it over into a tub of mercury, just like a regular barometer, the regular result of a raised column of mercury was 26 centimeters. But when taken to the top of the nearby Puy de Dôme, which was a mountain and the tallest one in the vicinity, when the column of mercury was measured, it only hit the 23 centimeter mark. Because of this, Pascal had concluded that the weight of air, which is different at certain elevations, was what the vacuum was being controlled by. And through this, Pascal had proved that a vacuum exists. This is important in our lives today because through this very simple little experiment, we now have a better understanding of our atmosphere and atmospheric pressure. Pascal had ended up developing a passion for philosophical work when he had a near-death experience when his horse had charged and left his carriage dangling over a river. Pascal had come out of the tragedy untouched, but spiritually, the tragedy had changed his life forever. So much so that Pascal had given up his works in math and science and pledged his life to Christ. So for 8 years until his death, Pascal had worked on theological treason, outlining his personal thoughts and surveying philosophical paradoxes, which was shown as leadership because he had written and called these topics a defense of the Christian religion. Pascal still lives on today. Because of his works in pressure, the standard units for pressure are called pascals. Pascal is also recognized as one of the most important writers in French literature, and is recognized as a master at French prose. The University of Waterloo in Ontario, Canada holds an annual math contest in his honor. Pascal probably didn't mean to leave this much of a legacy when he laid in his deathbed on August 19, 1662. He was only 39 years of age. But even though Pascal has passed, he still lives on through his legacy and his leadership.